Okay. So the base is a circle. The base is a circle, and height you can say, let's write it with the same notation what we have used, and we can say A, B, C, and maybe we can say O in the center. So cone would have a circular base, like the tents you might have seen. So see here, it is not even well made still, but this would be your cone. This would be your cone. In India, they will just turn it upside down, and they will make some mixtures and all in the trains. They will sell some mixtures in it. So yeah, so this is a cone which we are talking about, and the base is circular. Okay, and it could be even, base could be covered, it could be even empty. So if it is covered and they say find the surface area of whole cone, then you would consider that base as well. If it is empty, then only this conical face. So that cone has got height h, and it can have a radius r. Okay. If you cut open that cone, how does it look like? Any idea how the cone would look like if you cut open it? If you put a scissor,
like half a cone.
huh? You put a scissor.
Half a cone.
No, it would look like a sector. And is it well done? Something like this. It would be a sector. And then it would be a sector. And what would be this length? This one. This is your A, and B would like B, and this B dash, once you wrap it up, this point would come and sit on this point. Okay? It will come and sit on this point. This point will sit on this point. This one will sit on this. Okay? So this would be a sector. A sector, when you fold it, it will become a cone. Cone of height h and this radius r. Okay? So what would be this length? This one?
Radius. Be the radius.
No.
Wouldn't it be C?
What is C? What would be this one?
A to B.
Yes, it would be A to B. Very good. This one, this slant line which we are seeing, it is denoted by L, commonly denoted by L. Okay? And this is that L which would be here.
Yeah.
And this L can be calculated as, this you can consider as a rectangle, a triangle. This you can consider a right angle triangle where radius is r and height is h. So L would be equal to
R squared plus H.
root under r square plus h square. Okay? This would be your L. Understood?
Yeah.
And what would be this length? From B to C, B to B dash, what would be that length?
Circumference.
Circumference of what?
Circumference.
Yes, circumference of this circle. What is the circumference of this circle if the radius is r? The radius is r,
Pi.
circumference is
Pi.
2 pi r. Okay? So this sector, the B to B dash, it would be 2 pi r. Got it?
Yeah.
Hmm? So this sector is 2 pi r, and this length, this one, this is again, it becomes a radius of another sector. The L comes from here. L is equal to h square plus r square root under. So root under r square plus h square, that becomes your L.
Yeah.
And the perimeter of this circle
Wait,
is 2 pi r.
don't write C because C will get confused by that point.
Which one C? Okay.
B and C.
You can make it capital C, and this could be small c. Is it okay?
Yeah.
Yeah, maybe we don't have so many notations here, and I didn't plan it what to write, what not. So consider it is small c, which is this length, circumference of the circle, which is 2 pi r. Is it understood?
Yeah.
Huh? When you roll it, it becomes the circumference of the circle. And this one comes from h and r, square root of r square plus h square. So now, if you have to find it out, the area of this sector, can you calculate the area of this sector? Can you calculate? See, the face, the circumference of this cone would be area of this sector. Isn't it? Can you calculate the area of the sector? It has all been explained, area of the sector, in the last class, or maybe last class. I don't remember well. I think in the last class only. How we calculated area of the sector?
Also, area of a segment. I think.
Segment as well as the sector, both we calculated.
Oh yeah.
Are you getting confused with the segment and sector again?
No.
What we said sector and what we said segment?
Sector is that and segment is part of it.
Yeah, the segment was if we join this point to this point, and the remaining part of that would be a segment. If I know this radius, and if I know this arc length, can I calculate the area of it? How can we calculate?
Is it?
Think about it, apply a little bit of brain. Okay, this is the circle, and this is the center. And from here to that is that sector I cut, and I said this is my L, this is my 2 pi r, which is coming from this cone. Okay, is it okay?
Yeah.
So can you find it out, me, the area of this portion? That would be the area of the conical face of the cone.
2 times 4.
How we calculated earlier area of the sector? Do you remember?
Yeah.
How?
Pi, theta of 360
Yes, go ahead. Theta over 360
times
2
pi
times pi
R squared.
pi r square.
Yeah.
Pi, where r in this case would be pi l square.
Yeah.
Isn't it?
Yeah.
So if you know this theta,
Yeah.
you can, I think, calculate it.
Mm.
Huh? How can you find it out, the theta?
You do the opposite.
How can you find it out, this theta?
Times 360.
Oh, do you do that? Make theta on its own and then do
Yeah.
the calculations.
Times 360.
You make theta on its own.
See, the
360
theta
divided
by
pi
360, it is to say that what portion of this angle from the whole, isn't it?
Will it?
Now here, you know this is this portion, and you know the whole portion as well. This theta by 360, what you have learned earlier, can you replace with something? So see here, this is a ratio, theta by 360. This angle to the whole angle. If I say this theta by 360, I can write theta by 360 is equal to this sector. If I say, I was mentioning it A, B and B dash, because I said it will overlap. This sector, so this part to the total circumference. BB dash, that sector, sorry, this arc length to the total arc, total length, total perimeter of this circle. Perimeter, or you can say circumference of the circle. Would it be same or not? Theta by 360 means this angle, this is your theta, by whole 360 would be equal to, this ratio would be equal to this part, this length of the segment, to the total length of the circle, total arc of the circle, or total perimeter of the circle. Theta by 360 means this angle to the total 360 degree angle. This is total 360 degree. So this part to the total 360 degree would be equal to this part to the total circumference, isn't it? Got it? So this part to the total circumference of the circle. And what is the total circumference of the circle? Tell me.
2 pi.
What would be the total circumference of this circle? The circle which we are talking about. What is the radius of this circle?
L.
L. What would be the circumference?
2
pi
pi
L.
L.
2 pi L.
Yeah.
2 pi L. And what is this arc length? 2 pi R.
2 pi L.
So 2 pi R divided by 2 pi L. So it became R divided by L. So this one, theta by 360, you can replace it with R by L. So see here, what would be the area of this sector, which we said that it is this area of the sector. Let's replace theta by 360 by R by L. R by L into pi L square. And what it comes out to be? If you simplify, L would cross to square.
Is it R pi L?
Yes, pi R L. Okay, that became the surface area of the cone's conical face.
Oh, so we just replace RL by theatres over 360.
But now you know the surface area of the conical face is pi R L. But where does it come from? It comes from all this history behind it. It's not explained in the book. I just explained you for your interest. Hopefully in the exams nobody will ask you. But if you know, if you have this understanding, you can make your own judgment in solving many other problems. If the circular face is to be added in the area, then you will add it pi R square into it. If the base of the circular face is to be added. Understood?
Yeah.
So suppose you have to make a cone. So you decided that you want to make a cone the same way what cone we were trying to make it here. You decide to make a cone. So maybe you can do an experiment. So if I cut it here, we should have next time we should have all the scissor and everything with a proper sheet so that we can make it. Okay, so suppose I want to make, this is my this again not very well. Okay, this is your sector. It's not again symmetric and it will not form proper cone, but you consider this is your sector which is here, and you want to make a cone. So this L, this L, this L, and this small 2 pi R here finally would become a cone like this. Hmm? So this would be cone, and this is that circumference of this cone, which is coming from 2 pi r, because the radius of the circle is r, small r, and this is the height. This height, you would say, when you drop a perpendicular from this point to the center of the circle, that would be the height. And L is, as I said, L would be this length from here to here on this face. Okay, a height, anyway, I explained. Radius, you know, L would be this length on the conical face. Okay, this is L. Understood?
Yeah.
So L can be calculated by Pythagoras theorem, and that L becomes part of, once you open it, it becomes a sector, and this L is the radius of this circle, radius of this sector of the circle. Okay, so this was all related to area of cone, which finally you got. It is in simplified form, it becomes pi r L. Now let's talk about volume. And volume, again, I would not be able to explain you with simple explanation here. That volume you again need to learn from learn in the higher class. Where does it come from? But I will give you that formula, and it is same as, if I talk about volume, it would be same as previous one, 1 by 3 into area of base into height. Okay, area of base would be pi r square, and height would be that h. So I'm not explaining you here how it came from where from it came, but you remember volume is 1 by 3rd of area of the base into height, and area of the base is pi r square, and height is that height of that cone h. Okay.